All right, pre-Cal here we go. We're looking at video number 4, where we're going to look at radicals and their properties. So there are certain aspects to radicals that we need to take into consideration while we work with them. So here we go. To start with, root index. What is that? So what we say is something is the nth root. So what you're most used to seeing is that symbol, which is the square root symbol. So if we were to say a to the power of n equals x, then the nth root of of x is a, right? So it's the unzipping. Now, what that means is that's a little square root, but we don't draw the little 2, right? And then what you've maybe seen before is a symbol like with a little 3 there. Now you can have a 4 there or a 5 there. And what we get to is we get to an n, which means the nth root. And we just pick one. So the most basic that we deal with is a square root, and then a cube root, and then a fourth root. And what it means is how many identical factors do you need to have in order to be the square root or the cube root or the fourth root. And the number of identical factors is the index of the root. So as an example, we can take the square root of 4 because 4 is 2 times 2. So if you have 2 identical factors underneath a square root, that is the square root. The cube root of 8 is also 2 because now we have 2 times 2 times 2. So we have 3 identical factors. If you were to go up to, say, the fifth root of 32, well, 32 is 2 times 2 times 2 times 2 times 2. So the fifth root of 32 is also 2 because it's 2 5 times. So that is how the index relates to a root. So a square or a cube or a fourth root or a fifth root, so on and so forth. Now there are some important properties to consider about the root index. Now if we look at the root index first, as a is a positive number, so that means here we have our root, and a in there is positive, and then n is even. So as an example, for square root of 4 or the fourth root of 16, for instance, what we get in this scenario are 2 possible solutions. So you'll hear this all the time, 2 real roots, or in this case, well, yes, 2, because when we take a square root, it's the same number multiplied by itself. And 3 times 3 is 9, and negative 3 times negative 3 is also 9. So we're used to saying, oh, the square root of 4 is 2, when in fact the square root of 4 is equal to plus or minus 2. And the square root of 9 is equal to plus or minus 3. And the fourth root of 16 is equal to plus or minus 2. Because either the positive or the negative value multiplied by itself will give you a positive solution. Now, there is one subtle thing I want you to consider when we talk about this, because you'll see this as we move forward through the videos. If I were to ask you, what is the square root of 9, straight up like that, you would go, oh, the square, and you draw this, the square root of 9 is plus or minus 3. But if you're seeing it on the paper, and it already has given you that, and it was just that to solve, in that case, the answer is just 3, because otherwise they would ask you this version. They'd put the negative in front of it. So just be aware of that subtle difference. Once we're solving radicals, when you see it like that, you assume the answer is positive. Otherwise, they would give it to you like that. But when you're asked what is the square root of 25, yes, indeed, it is plus or minus 5. So a subtle difference, and I'll point out in the future videos when we get to it. So if you have an even root, so a 2 or a 4 or index, and a positive number underneath, you will have 2 solutions. So now, if a is negative, now this time we're going to have, say, the square root of negative 4 or the fourth root of negative 16. If n is even, so square root or fourth root, we have no solution. So we say a 0 with a line through it. Because what this is asking you to take the same number and multiplying it by itself. So either that or that in this instance. And if that is happening an even amount of times, you're always going to have a positive solution. So there's no way you could ever have a negative number under here. So if n is negative, if this value is negative and we have an even root, there's no solution. If n's positive, and then we'll have two solutions. Big distinction. And the last one is if the inner value, or if n here, if the root is odd. So sorry, let me jump back for a second. If n is negative, if a is negative, sorry, so if this value is negative and n is even, whereas here now we're saying if n is odd. So if n is odd, so we have a cube root or a fifth root, for instance, it doesn't matter if it's positive or negative underneath, because you're multiplying the same number by itself 3 times. So in this case, if I put an 8 here, well, that's just going to be 2 times 2 times 2. So the answer is 2. It's not possible for that to be plus or minus 2 because negative 2 times negative 2 times negative 2 is actually negative 8. So if you were to have the cube root of negative 8, well, it's just going to be negative 2. So you don't get the plus or minus solutions when this is odd. You just get one, either the positive value or the negative value. So this is what I was talking about with their special note on notation. Here we have 9. And if I were to say to you, okay, so now what's the square root of 9? So if you're given 9, and then you go, oh, well, the square root of that is plus or minus 3. That's correct. But if you're given this statement already as a square root, the answer is 3. And if you're given this statement already as a square root, the answer is negative 3. It's a subtle piece, but important when we get to solving because you don't want to give yourself extraneous values. So that's it for radicals and their properties. Be aware of them as we move forward because you're going to see them a lot, particularly with the plus or minus. The plus or minus helps us determine why we can potentially have two solutions versus why we can have one solution depending on the index of the root. Thank you very much, and I will see you next time.